So let us demonstrate that a data star can be held within a simple relational database environment such as Access. Throughout this demonstration we're going to be explaining that although this can be done, it would be much better in the long run to use a fully professional data warehousing tool where a lot of the selections of buttons, for example, would be done automatically for you. So what we're showing here is a very simple star with a facts about sales from a set of branches selling a set of products over certain dates. We can see the list of branches. In this example we have 10 branches based in Sheffield, which is in Yorkshire, which is in England, and a different branch is in Leeds in Yorkshire in England. So we have a branch ID and then as much information as we need to be able to do any analysis. We have a set of products, again roughly 10 products, with keys, numeric keys to give each row an identifier, followed by as much description as we will need during the analysis. We have a set of dates covering all the dates that we are selling our products. In this case we're going from the 1st of January 2015 right the way through to the very end of January 2015. And finally we have a facts table which in comparison to all the others is very, very long indeed. We can go right the way through to the 21,000 different records. In every single case each row says on a certain date in a certain branch a particular product was sold and this much money was raised and the profit from doing that was this much. So let's look at how an analyst might use this to query and get analytical data about the trends, for example, in their data sets. So in this case we are going to use the create and query design. Let's select all the tables and lay them out looking a little bit more like a star. So that would do it. You can see the facts table and the various dimension tables. And for example we could ask for all the different regions. Let's look at one of the measures, which is the sales value, and try running that as a query. However, in Access, if we do this, it will list out all 21,000 sales and just report the sales value and which branch it was in. It hasn't aggregated together all the different Yorkshire values at all. To do that we need to go back and select the totals, which raises this extra line here. We'd like to group all the Yorkshire values together, but we'd like to add together all the different sale values. So when we run this we now get a report that tells us the different counties and in total how much they have sold. This is much more useful to a manager analyst because they can straight away now see which the biggest counties are in terms of sales. It looks as if it's Yorkshire followed by Glamorgan. A typical analyst would then want to drill into the data, so they may go back to the design view and say not just which region, but they also might want to know which city sold the most. So we're now going to run a report that asks for all the counties grouped together, within that the cities, and within that, and then for those the sales values. And so we now see perhaps perhaps one of the reasons why Yorkshire had the biggest sales is it has 5 different shops in Yorkshire. It appears from this as if the amount of sales in the shops does vary, but it doesn't vary very much. The shops are by and large the same. One of the issues of looking at numbers like this is when there are too many of them, it's hard to see any patterns behind this. A graphical presentation would be more useful, and we'll come to see more professional packages for data warehousing that show graphics very easily. It's quite hard to get graphics from Excel, from Access. Let's go back to the design view, and instead of seeing the branch region and the branch city, we might ask about which day things are sold on. So we've changed the dimension into day name, and let's change that into looking at profits and run the query again. Again, what's happened? We haven't grouped properly, so let's go back and do the design. That was the issue. We've grouped, but we haven't summed. Again, we make the point that this Access tool is capable of running stars, but it's not very good at it, and one of the main issues is that it's necessary to be constantly reminding the package to sum the values rather than just let it report them directly. So there we go. These are the profits on the various days, and it looks like Sunday is our most profitable day. The least profitable looks to be Thursday. Again, if we could see that graphically, it would help. We've just seen an example where the analyst could select various columns from the dimensions and something from the measures table, the facts table, and look at data from a tabular point of view. But it was quite awkward to work out which the best sales day of the week was. Access can give us a visual presentation. To do this, we've cleared out the query altogether, and we'll start again. So we'll start and make a query design by selecting all the tables that are of relevance to us, and again arranging them back into what looks a little bit more like a star. Then we would like to see which the best sales day is, so we will drag in the name into the query, and we will look at the sales value, and be careful this time to remember to select so all Mondays are grouped together, but then the measures are shown by summing them. This time we will select to see a pivot chart, and in the chart we'd like to see a column for each day name, so that goes across the bottom as an axis, and for the height of the bars we'd like to see the sales values. And there, we've been able to draw a graph. This shows that it appears that Thursday across the year is the worst sales day, with trade building up and over the weekend, staying quite high over Tuesday and dropping down again. So it is possible to display graphs which are far more useful for being able to see the data quickly. Let's go back and try to change that. Instead of seeing it by day, let's switch to look by month, and then try drawing a graph again. Access, as we've mentioned, is not specifically designed for this sort of analytics, and quite often the menu choices aren't the most fluent. They don't always give you the best choices. So in this example, we need to bring back the field list, the choice of what we can add, and this time, since we've got month, we can now move this across, and now we can see the pattern of monthly sales as opposed to daily sales. And again, there seems to be quite a strong trend in this, that the summer months in the United Kingdom are the best selling, But as we head off towards Christmas and New Year, we don't get such good sales. And sum up what we've just been able to see, that it is possible to hold the tables for the dimensions, in this case 3 dimensions and 1 facts. The facts table is entirely numeric, nothing but numbers within this table. Although it's very, 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 very long, it doesn't take much storage sideways. For dimensions, they tend to be many fewer rows, but each row, because it's in text, can be quite lengthy. And we've also seen that it's possible to create queries which where the user can select which fields they want to look at, and for dimensions they would group the things so that all branches of the same name get reported in the same line, and then they can add up, they can aggregate the different measures. But as we've said several times, Access isn't the best tool for presenting this. For example, the end user would never want to be able to see the technical branch ID. For example, that was 201. They would not want to include those in reports, but there isn't an easy way in Access to hide all of these extra values from the user. When we see more specifically designed for use packages, we'll see they're much, much easier to use. So the key point is, it can be done, but really this tool is not the best one for doing it.